Hello everyone and welcome to Robotics and Control Engineering tutorials. In these tutorials we present real and applicable knowledge of control engineering, robotics, machine learning, optimization, applied mathematics, etc. In this robot operating system or ROS tutorial we will learn how to model, visualize and simulate a simple robotic system or a manipulator that you can see over here. To simulate this simple manipulator, we will be using the RViz program. This simple manipulator consists of two joints and three links. The first joint is placed over here and it's a rotational joint. Let's illustrate the rotation. Over here, I can rotate the first joint. And as you can see, the rotation is performed with respect to the vertical axis. The second joint is located over here and it's a prismatic or translational joint. By adjusting this button, I can translate this joint. And we can have combinations. For example, this joint gives me rotation and this joint gives me translation. To make this video tutorial as clear as possible and not to blur the main ideas with too much complexities, I deliberately selected a relatively simple robotic configuration. However, everything explained in this video tutorial can be generalized to very complex robot kinematics and geometries. Since this will be a very long video tutorial, I will split this video tutorial into two parts. You're currently watching the first part. In this video tutorial, you will learn how to write this file that completely defines the geometry and kinematics of our robotic system. This file is called the URDF file and it's a very important file for ROS modeling. But before I start with explanations, I would like to briefly mention the following. It took me a significant amount of time, energy and planning to create this completely free video tutorial, as well as almost 300 video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thank you very much. Okay, let's start. Since I was a professor in the US for almost 8 years, I tend to give my students a brief overview or syllabus of this video lecture. And here are the lecture outcomes. The first goal of this lecture is to learn the basics of robot modeling in ROS. Then the second goal is to learn the basics of URDF robot file. Then the third objective is to learn how to visualize robot models in RViz. Fourth objective is to learn how to write a launch file. And the fifth objective is how to move robot joints in RViz. The first question that we need to answer is, what is a URDF file? URDF stands for Unified Robotics Description Format and it's an XML format file for representing a robot model. The next question is, what is RViz? RViz is an abbreviation for ROS visualization. It's a powerful 3D tool for visualizing the robot model and for visualizing information obtained by sensors attached to a robot. RViz can be used to visualize 3D data collected from stereo cameras, Kinect, as well as other 3D sensors. We can also use RViz to visualize images from cameras and laser range finders. Another nice feature of RViz is that if our robot is communicating with the workstation running RViz, and later on you will learn that RViz is just a node, RViz will display the robot's current position and configuration by using animations. Here it's very important to emphasize that all the codes created and explained in this video tutorial will be posted on my GitHub page. A link to my GitHub page is given in the description below this video tutorial. In this video tutorial I'm using ROS noetic distribution. Then, the first step is to install or verify installation of the necessary packages. Usually RViz comes with ROS noetic. However, it's still a good practice to verify the installation of RViz. the best way to verify the installation is actually to try to install this package. For that purpose, let's open a terminal and let's adjust the size of the terminal. Let's try to install RViz. And over here you can clearly see that I already have RViz on my computer. However, in your case it might happen that you will actually install RViz. So far so good. Let us now verify that RViz is actually working. To do that, open a new terminal and start your ROS core. ROS core is a master ROS that kind of runs in the background, and every time you want to run something you will first run ROS core. Consequently, over here I started my ROS core. RViz is actually just a node inside of the complete ROS world. Let's go back to our original window and let's type ROS run RViz to verify that RViz is working properly. And voila, here it is. Here's the RViz window, and apparently it works properly. Close RViz and let's close our ROS core. Okay, the next step is to install this package. This package is very useful for visualizing the structure of our robot. That is, by visualizing the structure of the URDF file. Next, we need to create our workspace and our Catkin package. To do that, we need to create a folder, and inside of this folder we need to create the source folder. Then we need to run Catkin make. Let's perform these steps. Let's check the structure of our home folder. Okay, and over here we see the folder that we just created. It's called robot WS. WS stands for workspace. Let's go to that folder. And let's see the content of this folder. We have this source subfolder. Next, we need to create our workspace. To create our workspace, we'll be using Catkin make. Okay, it's a good practice to double check all the messages and to search for errors. No errors or warnings. So far, so good. Next, we need to source our new environment, that is our new workspace, and we need to verify the path. Consequently, we need to type this command. And let's verify the path. Okay, over here I can see that the path is correct. That is, I'm seeing robot workspace and I see source. Perfect. Let's create our package. To create the package, I'm using this command. The main command for creating the package is catkin create package. Then I specify the name of the package. I will call the package robot model package. However, you can change this name as you wish. And over here, I need to specify the dependencies. The dependencies can be seen as standard ROS packages that we will include in our package. And let's see these dependencies. The first dependency is ROS CPP. This is basically a package that enables us to use C++ in ROS. The second dependency or the second package is TF2. TF2 lets the user keep track of multiple coordinate frames over time. The third package is geometry messages. This package is basically analyzing and making sure the messages for common primitives such as points, vectors, and poses are working properly. The next package is URDF. This is a C++ parser for URDF package. This package is RViz, and the final package is joint state publisher GUI. This basically package contains a GUI tool for setting and publishing joint state values for a given URDF. Let's create the package. To create the package, I first need to go to my source folder. And in the source folder, I need to type the command. And here it is. We will see our folder for our package, and let's go to that folder. Next, inside of this folder, we need to create two additional folders. The first folder is URDF, and this folder will store our URDF file, and the second folder is launch folder. Consequently, let's create these two folders. And let's create the second one. Let's double check everything. Perfect, I'm seeing URDF and I'm seeing the launch folder. Next, let's create the URDF file that will define the robot geometry and the robot kinematics. Consequently, let's go to the URDF folder. And inside of this folder, we will create a file. We will use the gedit to create a file. Here's the file. It's completely empty. To make this video as short as possible, I already created the URDF file and it's given over here. I will simply copy and paste pieces from this file and I will add them to my file given over here. To make this video as clear as possible, I will first create a robotic system with a single link. Then I will explain how to visualize this robotic system in RViz, and then later on we will add other joints and other links. So here is a robotic system with a minimal configuration. This robotic system consists only of a single link. The URDF file starts with this line. You should not change this line. We can write the comments like this. We use this set of characters to start the comment and this set of characters to end the comment. And over here, I'm just specifying a link to the page that describes the robotic link. Here is a very nice figure that explains what is a link and what is a joint. Here's our link and here's a joint. Joint is the part of the robot that we can move, that is rotate or translate, and a link is simply a hardware link of our robot connecting two joints. Okay, and over here I'm just defining a single link. Next, I need to define the name of my robot. Over here I call the robot simple robot. Then I need to define the actual link. Here's the start of the definition and you need to search for the end of definition. Here is the end of definition. Consequently, everything inside, starting from here until here, is actually the link definition. Let's go back to this nice sketch. Next, I need to define a visual part of my robot. That is, the part of my robot that will be simulated in RViz. For that purpose, I'm using this environment visual, and I need to close the visual environment. Then inside of the visual environment, I need to define my geometry. My basic geometry of the link is simple cylinder of the length 0.05. That's the height of your cylinder, and the radius is 0.2. Over here, I specify two comments that explain what is RPY and XYZ. And this is very important for defining the origin. Now, origin is very important. RPY is the following. R is roll, P is pitch, and Y is yaw. Consequently, we have 0, 0, 0, so no rotation in Eulerian angles, and X, Y, and Z are offsets. I keep X, Y, and Z 0, 0, 0, that is no rotations and no offsets. So the coordinate system of my link is defined like this. And over here I can define my material properties. Material name is yellow, and also I can define some other properties. However, I'm trying to keep this code as minimal as possible. And I need to close my material environment. Then I'm closing visual, closing link, and I'm closing my robot environment. Notice over here that the definition of the robot starts here and ends here. Let's save this file. Okay. Next, close this file and go back to the terminal. The next step is to define the launch file. Consequently, I need to go to the launch folder. Inside of the launch folder, I need to create a file that's called robot.launch and press enter. Here is an empty launch file. This file is very important since this file will define the configuration for starting RViz. And in order to make this video as short as possible, I will simply copy and paste the launch file that I defined previously, and I will change this file accordingly. Again, this line is always the same. Here we start the launch environment and we end the launch environment. Over here we need a few parameters. Arg name is model, parameter name is robot description, and over here we need to specify the path to our robot.urdf file. Consequently, over here I need to change the name of the folder. My URDF file is actually located at this folder, and I need to specify this parent folder. So the name of the parent folder is robot model package. Robot model package. Double check that this part is correct, that is that the path completely matches to the path of our robot.urdf file. So let's verify. We see robot model package, URDF, and inside of the URDF we have the file called robot.urdf. Perfect. The next step is to define and to specify several packages or nodes that will be started together with RViz. The first package is join state publisher GUI, and here's how we define this environment. The next package or node is robot state publisher, and the third package or node is our RViz. Over here we need to make a small modification. That is, we need to enter the correct path. So I will simply copy and paste this part from here to here. And here's another comment. First time that we start RViz, this file will not exist. Later on, I will use RViz to create this file. This file is a configuration file that's used by RViz to store the configuration and other properties that we will manually change. Next, save robot.launch file and close the file. Go back to the terminal. The next step is to run the make command once more. For that purpose, let's go back to our original workspace, and in our original workspace we need to run catkin make. Okay, now we are ready to run our launch file. To run our launch file, we need to perform two steps. The first step is to open a new terminal and to run the ROS core. Then go back to the original terminal and type ROS launch robot model package and specify the name of the launch file. And let's see the result. Okay, here's our RViz. However, we see one problem over here. Where is our link? Where is our robot? To visualize the robot, you need to perform two steps. The first step is to specify fixed frame. In our case, it's base link. And if you remember that when I define my URDF file, so let's pull out the URDF file, you can basically see that the link name is base link, and consequently you need to specify the base link frame. Let's visualize our link. Click on Add, and over here you need to find a specific option. We need to select Robot Model and click on OK. And voila! Here is our first link. It's a cylinder with a specified height and radius. Let's see the height and let's see the radius. The height is 0.05 and radius is 0.2 and color is yellow. Perfect. Here it's very important to save this configuration such that next time we don't need to lose time by searching for robot model and for adjusting the fixed frame. To do that, I will click on File and I will click on Save Configuration As. Over here, I need to find the path to my Robot WS. So let's find the path. So it's under Home. Here's Robot WS. I need to go to Source, Robot Model Package, and over here I need to specify the name of the file. The name of the file is robot.rviz, and this name should precisely correspond to the name inside of our robot.launch file. Okay, let's do that. Let's save everything. Perfect. Let's test. We close the window, we go back to the terminal, and we launch RViz once again. And voila, we can see that RViz completely saved our configuration. That is, we don't need to adjust robot model and fixed frame. Okay, this is the end of the first part of this tutorial. I will continue with explanations in the second part of the tutorial. In the second part of the tutorial, I will add other joints and other links. I hope that you like this video. If you like the videos I create, please press the like and subscribe buttons. Thank you very much.